All right, part 3 of our video on the homework solution. All right, we wanted to perform the frequency count. We had just finished reading the array data in from our file. We're using this test data set here, the small test data set. All right, so frequency count, if you don't remember that, go to the prior homework where we perform that. There's a video as well talking about how to perform a frequency count. What I've done is I've added a constant here, right? Frequency array size. Right now I've set this equal to 10, right? We said in the homework numbers are going to range from 0 to 255, but in this case, in this first example, we just are using numbers that go from 0 through 9. So I just want to go back to that simple example, which should be familiar from that other homework, right? I created the frequency count array. It's of this size, right? There's 10 unique values in the range 0 to 9, and initialized all of those counts to 0. Right? We can declare this right before we run at compile time because it's always going to be the same size because we said that's the problem we're solving, right? A guaranteed range of numbers. All right, so down here in the file that I've got comments for the frequency count. So we already created the array. The array size is the number of unique values, right? The data ranges range from 0 to 255. We initialize the counts to 0. So let's just, that was part of our pseudocode for what we needed to do. So I'm going to add those comments up here, why we're adding these variables. And so down here, we want to read through the file data created above, counting the zeros, ones, twos, threes, etc. Right. Our data is stored, right? What came from the file is stored in file data. These are how many elements are in it, array size. So we could just simply iterate through this for int I equals 0, I less than array size, plus I, and let's create a variable int value, and let's just read and store that into value for clarity. So we're going to read from our file data, right? We're going to loop all the way through from index 0 all the way to the last index, and we're going to read that and store it here in value. So this value, right, in our case of where we're just going 0 through 9 now, is going to be number 0 through 9. And we just use that, right? Our frequency count array, we use that value. That's the index of the number we're counting. So we're just going to say plus equal 1. In other words, when values is 0, at index 0, we want to store a count of 0, so on and so forth. So let's actually just go ahead and run through this code. Let's see if I can do a run to cursor here. All right, so over here in the watch window, I've got the name of the array, file data, right? That's our uncounted data. So in Visual Studio, in parentheses, if I put the name of the array and then plus an offset. So I want a 0 offset, meaning I want to start with the first array element. And then I've got 15 in that array. So I said, I want you to show me all 15. So by doing that here in the watch window, it shows us each value and its associated index. All right. Frequency count, you can see this particular array, right, goes 0 through 9. Everything's initialized to 0. And so now if I hit F10, right, I is going to be equal to 0. We're going to read this in. So file data at index 0, and actually I can add the I in here if we want to watch that. So file data, right, at index 0 actually happens to be the number 0. So we should see the number 0 being stored then in value. So I'll pop this up. Value got the number 0. So we want to count. We want to add 1 to our count of zeros, right? We're going through the array. This is the first 0 we've seen. We're going to add 1 to that count. So we use that value, right, which is 0, to add 1 to that index location, which will be here. All right. Frequency counted index 0 says we're going to add 1. We counted 1 0. So F10, you can see then in this array that we added 1 to that count. We'll loop back through. So F10 is what I'm hitting to go through. I is going to become equal to 1. 1's less than array size. We're going to read the value stored at index 1, which actually happens to be the number 1. So we're going to add 1 to our count of ones. And you can see that happened here. Frequency count, index value. Well, value is 1. We added 1 to that count. Right. F10, we go back up. I becomes 2. So we're going to go to file data at index 2. So file data at index 2 happens to be the number 3. So we want to add 1 to our count of 3s. So F10, you can see value has the number 3. We're going to add 1 to frequency count at index 3. We added 1 there. Oh, as you keep going through the array here, we should go through all 15 of these. Right, we're reading them in, we're storing our count. I'm just hitting F10. Okay, finally I became equal to 15 and that. And if we go back to our test data set, right, how many zeros do we expect? There's 2 zeros in here. So let's look at frequency count. Frequency count index 0, there's our count of 2. How many ones? There's 1, 2, 3. 3 ones. Good, we got 3 ones. How many 2s? I only see 1, 2. There's 1, 2. How many 3s? 1, 2. There's 2 3s. All right, we've got 1, 4, 1, 5. 4, 1, 5. It looks like we've got 1, 6, 1, 7, 1, 8, 1, 1, 1. And then finally the number 9 occurs twice. We've got a count of 2. So that's how we were able to go through our array data, right, that came from the file. We were able to perform the frequency count, and now we have that stored here in this array. Right. And so like I said, we did that in main. Now, can we do this in its own function? Could we write a function to do this that we can call? So let me stop the debugger. Well, let's look here in main. What did we need? Well, in main, we had to have access to the file data. We needed to know how many elements were in that array, and we needed access to the frequency count. We don't need to know the length of the frequency count array, right? We're going to assume that all the values that we read in are in the range 0 through 9 and will not be beyond our bounds. Let's just go ahead and put this information. So let's go over here. Oh, I think I'd call this helper. Now, I was using all these helper functions to read array data. Maybe I want to make a new file called stats. So I'm going to add a new CPP file. And I'm just going to call this one. Maybe this is my statistics that I'm working on. And we're going to, all right. So over here, I just copy pasted this in from main. We said, what do we need? Well, we're just going to, I'm going to call this create frequency count. And then we are going to need access to the array. So pointer to A. We're going to need array size. And we're going to need a pointer to the frequency count array. And I'm going to declare this value. Actually, just going to put this inside. Right. So here, right, instead of calling it array size, I called it A size. You can call it the same thing if you want. Here, instead of file data, my parameter name is A. And then I was calling this FC for frequency count. Or I could certainly give it a more meaningful name like frequency count. All right. This function doesn't need to return anything. Now, we're not going to change the contents of what's in A. We're just reading that. So we can put the const modifier here that makes that array read only. And let's see, you probably want to put some comments in there. Let's put in some good comments. A is the array size. I don't need the size of the frequency array. So A is going to be the array containing the data to be counted. A size is the number of elements in array A. FC is the frequency count array. And then we're going to tell the user we're going to have a note that all elements in the frequency account array should be initialized to 0 before calling this function, right? Meaning if we just want a count of what's in there, right? If they had other garbage in there, the count wouldn't be good. And then upon completion, the array FC contains a count of the number of zeros, ones, twos, etc. found in array A. All right. And so we are going to also need, since I created a CPP file, right, we're going to need a file, a header file, a matching header file. So I'm going to add that new item, choose header file. I'm going to give it the name of stats. So we have stats.h and stats.cpp. All right, header guard is going to end in end if. Copy the com. All right, if not defined. So if not defined, we make this symbol, right? And so I'm going to call this stats underscore h included pound define. So if that's not defined, we want to go ahead and define it. Stats h included, right? All of our prototypes and everything go inside this header guard that ends with end if, which means forgot to copy this. Our prototype. And then over here, we need to include stats.h, right? It's local. We put the double quotes around it in main. We also need to include stats.h now. So we can use the file, the functions we define in that file, in those files. All right. And so now here to perform the frequency count, we could simply just we call that function create frequency count. So we want to pass the A, we want to pass here in main, it's file data, its length is array size, and here the name of our array is frequency count. All right. And that should perform then the same function. Right. Yeah, so let me clean out the old stuff. Let's build the new. And so run the cursor. I'm going to hit F10, which will execute all of the code in this function. And so, all right, so these things no longer exist in main, value and I. But you can see back here in frequency count, if we go back through, we have these same values that we did before, right? It counted everything. So I'll stop the debugger, right? So we now have a function that performs the frequency count for us, right? And remember, once again, we're just working with this small data set for right now. All right, so that's the end of how we perform the frequency count. The next thing we'll work on is how do we work with the grouping. That will be in the next video.